psychology and classical physics, providing valuable insights into its structure and functions. However, quantum physics, a branch of science dealing with phenomena at the atomic and subatomic level, offers radically different principles, such as superposition, entanglement, and wave-particle duality. These concepts challenge our understanding of reality itself. As we dive into the speculative but fascinating connection between quantum physics and brain function, we'll explore fundamental particles, key theories, challenges, and the groundbreaking implications this frontier could have for consciousness, artificial intelligence, and more. Understanding quantum physics. The basics. Quantum physics, also called quantum mechanics, is the science of the very small, atoms and the subatomic particles that compose them. At this microscopic scale, the rules of classical physics, which govern our macroscopic world, no longer apply. Instead, quantum mechanics introduces phenomena that defy our intuitive understanding of nature. Let's briefly examine these key principles. Superposition. Particles like electrons can exist in multiple states or locations simultaneously. For example, an electron can be in two places at once until it is observed or measured, at which point it chooses one state. Entanglement. Two particles can become so deeply connected that the state of one directly and instantaneously influences the other, no matter the distance between them. Albert Einstein famously called this spooky action at a distance wave-particle duality. Particles like photons and electrons exhibit both wave-like and particle-like behaviors. They can behave as particles, localized entities, or as waves, spread-out probabilities, depending on how they are observed. These principles have been rigorously tested in the laboratory and underpin much of modern technology, from lasers to quantum computers. But how might these principles relate to something as complex and macroscopic as the human brain? The brain through the lens of neuroscience. The brain is one of the most intricate structures in the known universe, composed of approximately 86 billion neurons, each forming thousands of connections with others. It's the control center for everything we do, thinking, feeling, moving, and perceiving the world. Traditionally, neuroscience has relied on classical physics to explain brain function. Neurons communicate via electrical impulses and chemical signaling, transmitting information across synapses. This process appears to operate well within the bounds of classical physics, with no apparent need for quantum mechanics. Yet, some aspects of brain function, such as the emergence of consciousness, the speed of decision-making, and the efficiency of neural processing, remain mysterious. Could quantum processes offer an explanation? The hypothesis: a quantum brain. The hypothesis that quantum mechanics might underpin brain function is highly speculative but thought-provoking. Proponents argue that certain features of the quantum world, like superposition and entanglement, might play a role in processes such as consciousness. Could consciousness arise from quantum processes within neurons? The elusive nature of consciousness has long puzzled scientists, and some believe that quantum mechanics might hold the key to understanding it. Decision-making. The brain's ability to process vast amounts of information and arrive at decisions rapidly might resemble the parallel processing observed in quantum computers. Creativity and problem-solving. Quantum superposition might allow the brain to explore multiple solutions simultaneously, enhancing creativity and complex problem-solving. Let's delve deeper into the potential roles of fundamental particles in these processes. Fundamental particles and the brain. To explore the quantum brain hypothesis, we must understand the fundamental particles that might be involved. These particles are governed by quantum mechanical principles and form the building blocks of the universe. Photons. Photons are particles of light that carry electromagnetic energy. They exhibit wave-particle duality, meaning they can behave as both particles and waves in the context of the brain. Photons are involved in electromagnetic interactions, which could influence neural signaling. The brain produces and interacts with biophotons, weak emissions of light from living tissues. Some researchers speculate that biophotons might play a role in quantum communication within neural networks. Electrons. Electrons are negatively charged particles essential for chemical bonding and electrical conductivity. Their quantum behaviors include wave-particle duality and uncertainty in position, the Heisenberg uncertainty principle. In the brain, electrons are crucial for synaptic transmission, the process by which neurons communicate. The quantum properties of electrons could theoretically enable quantum computational processes in neural activity. Neutrons. Neutrons are neutral particles found in atomic nuclei. While they don't directly participate in electrical interactions, their stability is essential for the structural integrity of atoms and molecules in the brain. Neutrons contribute to the stability of the molecules that form neural structures. Though not directly implicated in quantum processes, they provide the framework for potential quantum interactions. Protons. Protons carry a positive charge and define the identity of elements. Like electrons, they exhibit quantum behaviors in the brain. Protons influence the chemical properties of molecules, shaping the environment for neural activity. Their quantum mechanical behaviors could subtly affect molecular interactions at the atomic level. Key theories in quantum neuroscience. Orchestrated objective reduction, OR theory. Proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff, the OR theory suggests that quantum coherence occurs in microtubules, tiny structures within neurons. According to this theory, microtubules act as quantum computational units. Consciousness arises from quantum processes occurring in these structures. While this theory is highly controversial, it has sparked significant interest in the scientific community. Quantum decision-making. Another theory posits that the brain might use quantum superposition to evaluate multiple possibilities simultaneously. This could explain how we make decisions quickly and efficiently, even in complex situations. Quantum consciousness. Some philosophers argue that consciousness itself is a quantum phenomenon, emerging from the entangled states of particles within the brain. This idea remains speculative and lacks empirical evidence, but is a topic of philosophical debate, challenges, and criticisms. Merging quantum physics with neuroscience is no easy task. Several challenges must be addressed. The warm, wet brain. Quantum coherence is notoriously difficult to maintain in warm, noisy environments. The brain's warm and wet conditions seem inhospitable to quantum processes. Lack of empirical evidence. Direct evidence of quantum effects in the brain is currently lacking. While intriguing, the quantum brain hypothesis remains speculative. Interdisciplinary complexity. Understanding quantum neuroscience requires expertise in both quantum physics and biology, fields with vastly different methodologies and paradigms. Real-world implications and future directions. If quantum processes are indeed involved in brain function, the implications could be revolutionary. Advancing neuroscience. Quantum theories could provide new insights into consciousness and cognitive processes. Artificial intelligence. Understanding quantum computation in the brain could inspire the next generation of AI, enabling machines to think and learn like humans. Medicine. Quantum neuroscience might lead to innovative treatments for neurological disorders, such as Alzheimer's disease and depression. Ethics and philosophy. Discovering quantum mechanisms in the brain could reshape our understanding of free will, morality, and the nature of reality. The journey ahead. The intersection of quantum physics and neuroscience represents a burgeoning field filled with possibilities. While much remains speculative, the potential for groundbreaking discoveries is immense. As technology advances, we may one day uncover the quantum underpinnings of brain function, or find new, equally fascinating explanations. For now, this exploration invites us to appreciate the intricate beauty of the universe and the mysteries of the human mind. Do you think quantum physics holds the key to understanding consciousness? Share your thoughts in the comments below, and don't forget to subscribe to Professor's Diaries for more explorations into the mysteries of science and the mind.